two polygons are similar if their corresponding angles are congruent. So in order for two shapes to be similar, their corresponding angles must be congruent. That's really important. It's really important to do those checks. It's really important to understand that fact. And the lengths of the corresponding sides are going to be proportional. All right, if they're proportional and everything is congruent angle-wise, you're going to use this symbol to compare them. That is, your symbol is read similar to. So your two checks to see if two things are similar are A, you're going to check for corresponding angles being congruent, and then you're going to check for corresponding side lengths being proportional. We're going to do that check on this one, although the angles is pretty redundant. So we just need to check to make sure corresponding angles are congruent. Well, according to our drawing, angle A is congruent to angle W. Per our drawing, angle B is congruent to angle X. Per our drawing, angle C is congruent to angle Y. And finally, we have angle D is congruent to angle Z. So according to our angles, they can be similar. According to the angles, they can be similar, but the sides have to be proportional. Now to check to make sure the side lengths are proportional. So make sure on the test, if I say show me that these two things are similar, you have to do these two things to show me they're similar. The second thing is corresponding side lengths, making sure that they are proportional. So that means, well, first of all, if angle A is congruent to that, B is congruent to that, that must mean these two lines are supposed to be proportional to each other, 15 and 5. In other words, our corresponding side lengths are going to be AB should be corresponding to WX. Well, AB's length is 15. WX's length is 5. So the ratio between those two things is going to be 3/1. Let's check out our next corresponding sides. I'm going to use B and C next. So BC needs to correspond with XY. Well, BC equals 12. XY equals 4. Once again, that equals 3/1. So far, everything's proportional. Let's check out the last two. So the next one, let's do CD over YZ. CD is 21. ZY is 7. So that is going to be, well, that's going to be 3/1 again. We're good. We just have one more side to check. That is our AD and our WZ. So AD and our WZ. AD is 18. WZ is going to be 6. That is 3/1. These two shapes are similar. I needed to check all of that to show me for a fact that they're similar. All right, we can't just look at it and go, looks pretty similar. You have to know that. After I say all of that, then I can finally say, here's my similarity statement right under there. I can say that A, B, C, D is similar to W, X, Y, Z. Order matters. Order matters. So based upon what I just wrote there, A, B, C, D is similar to W, X, Y, Z. Without seeing a picture or any other bit of information, I know that A is congruent to W, B is congruent to X, C is congruent to Y, and D is congruent to Z. So order definitely matters. You might want to write that down somewhere on that. Order matters. That we know just from like when we did congruent triangles, how order mattered. Same thing here. Order matters. What matches up is congruent. It also tells you that AB is proportional to WX, BC is proportional to XY, CD is proportional to YZ, and ZW is proportional to DA. We get all that from that one little statement. All right, that is similar polygons in a nutshell. The next thing we're going to talk about is scale factor. Scale factor is basically how we're going to solve anything at all. And it is the ratio of the lengths of the corresponding sides of two similar polygons. So this says in the diagram, triangle ABC is similar to triangle XYZ. That tells me from that statement that A is congruent to X, because they're the first ones in the statements. Our middle ones are B and Y, so B is congruent to Y. And finally, C has to be congruent to Z. I state that for the fact that we have to make sure that 3 and 6 are supposed to match up together. And in fact, they do, because A is congruent to X and B is congruent to Y. So that 6 and 3 are going to match up. So the scale factor from ABC to XYZ is going to be 6, or let's go with AB over XY, because those are the corresponding sides, which is 6 over 3, which is going to be 2 over 1. Note I leave it as the fraction 2 over 1. I just leave it as the fraction 2 over 1. All right, the next question is the scale factor of triangle XYZ to ABC. Just like any ratio, the order in which you number stuff is very important. So ABC to XYZ is probably not going to be the same thing as XYZ to ABC, because XYZ would mean XY would be on top, where AB would be on the bottom, which would now give me 6 over 3, which would be 1 over 2 instead of 2 over 1. Little star there. If two polygons are congruent, they are similar. It's just their scale factor is 1 to 1. So some two things that are congruent can be similar, or they are similar automatically. So if I ask you to show me something is similar and you show that they're congruent, you showed me they're similar as well. Yes?
Wait, so you're saying that if something is like the same but it's like opposite, so you're saying that those could be similar? Or...
Same but opposite?
Yeah, or is it because of order matters they wouldn't be similar?
I don't know what you mean by opposite, I guess.
Oh, because like you did AB, XY, 6 over 3 equals 2 over 1.
Mm-hmm.
And then XY over AB, 3 over 6 equals 1/2. So like those wouldn't be similar because order matters.
They are similar. Both those triangles are similar. We started off with them being similar. They're just asking about scale factor.
Oh.
Basically, how do I get from my big one to my small one? That is 2 to 1. My big one's 2, my small one's 1. This is asking, how do I go from the small one to the big one? And that is 1 to 2, so it just switches the order I say it in. It's still the same ratio, it's just, I'm saying it in a different order.
So does it mean that order wouldn't matter to this rule, or is it?
Order matters in scale, when I ask you this to this.
Oh, like the ratio?
It's kind of like the ratio when I did boys to girls versus girls to boys. The ratio, I didn't change the number of girls in the classroom, did I? No. It was just a different way to present the same material.
Oh, okay.
This is just a different way to present the exact same material. All right, using similar figures, we are going to use that scale factor that we just figured out how to do. And proportions. To solve problems involving similar figures. In similar polygons, the ratio of any two corresponding lengths is proportional. And what do I mean by that? Well, what I mean by that is if we look right here, if to get from AB to YX is 2 over 1, to get to any other corresponding side, we'll have the exact same ratio. So if I looked at AC to XZ, the ratio will still be 2 to 1. This one will be 2 to 1 to that one. So as soon as I get one side's proportion, I have the ratio for every single side. That's what this statement's saying right now. So our scale factor is really just find it once, and that's your scale factor for everything, for every single side. So we don't have to show a scale factor every single time. It's kind of like if I knew the scale, notice on this one, the scale factor was always 3 over 1, no matter which side I was looking at. That's how it is in any similar polygon. All right, second thing, if two polygons are similar, then their perimeters are proportional. To the scale factor of the two triangles. So once again, let's use this as our example. Our scale factor here is going to be 3 over 1, which means if I add up if I find the perimeter of this to the perimeter of that, that will have the ratio 3 to 1 as well. So if I added all of this up and divide it by this, we'd come up with the fraction 3 over 1 as well. So it's kind of cool that all of it is preserved with that 3 to 1. We just got to find that one key, and it unlocks everything. That's why I said our scale factor is probably the most important thing we're going to be finding. Scale factor first, everything else after, because that's our key to solve most of our problems. All right, there's pencils flying. Here's my example. So we have ABCD is similar to EFGH. I'm going to pause before I even read the question on it. Because a lot of times in these questions, on a test, one of the easiest things I'm going to ask you is, well, what's the measure of all the angles? So what you're going to say is, well, similar polygons have congruent angles. That was that big thing I highlighted, and I said it was super, super important. Corresponding angles are congruent to similar objects. So if A is 60 and A is similar to E, 60, E has to be 60 degrees as well. If F is 100 degrees, that means B has to be 100 degrees. If C is 90, G has to be 90 degrees. And there is no number for H and D, so it's impossible to solve those, correct?
No.
Sabrina?
Oh, I can't see that number.
Oh, which one?
The one next to E or B.
The one next to B. Oh, that's 100.
Oh, okay.
Did that get moved? Is the angle really bad or something?
Oh no, I just got from the angle.
Oh, okay. All right. If the angle's bad, we can just move that stuff too. Yeah.
You can find it by doing the sides, like the equation like n minus 2 times 1.
Mm-hmm.
And then, so if you did like n minus 2 times 180, it would be both sides minus 2, and so it would be 360.
It'd be 360. So it's 360 total degrees. If I take 360 minus 60 minus 100 minus 90, we come up with 110. So this one must be 110. This one must be 110. So although I didn't ask you to do it, on the test, that's a super easy question for me to ask that you should get correct. It's pretty easy just to match up our angles. Yes?
So like, what I don't understand is like, since is this like a trapezoid?
Doesn't matter.
Oh.
It's just four-sided figure.
Well, like, wouldn't they have to equal 180 degrees?
They have to equal 360. Because just like what was said, we use that n minus 2 times 180. There's 4 sides minus 2. 2 times 180 is 360. There has to be 360 degrees in here.
So the whole thing has to equal 360?
Interior angles have to add to 360.
But it doesn't matter if two sides equal?
Nope. It's just a four-sided figure. Okay. So it says, what is the scale factor between ABCD and EFGH? So what I'm going to do right there, and this can save you guys a lot of heartache. If it listed ABCD first, I'm going to call ABCD the top. I'm going to call EFGH the bottom. And I would do that almost every single time I have a problem like this. It's going to keep your fractions consistent and making sure everything stays the same. So anytime I'm talking about an element from here, it's going to be on the top of my fraction. Every time I'm talking about something down here, I'm going to be talking about the bottom of my fraction. So now I'm going to look for two numbers that match up. Well, the 6 and 18 match up. Is the only two numbers that match up, because this 5 goes to nothing, this 9 goes to nothing, this 21 goes to nothing. So I'm picking the side that matches up between the two. So my top is that side DC. My bottom fraction is going to be the HG, and DC equals 6. HG is going to equal 18. We can go ahead and simplify that down to 1 over 3. 1 over 3 is my scale factor for everything.
Do you have to show the equation? Can you just like...
You could just say it's 1 over 3. But hey, pay attention to me right now. If I say A, B, C, D, 2, E, F, G, H, A, B, C, D better be on the top. It better be 1 to 3. 3 over 1 is not correct on this. 1 over 3 is correct. 3 over 1 is not correct, just because of the order I put this in. Order matters with ratios. All right. Then it says, what is the perimeter of A, B, C, D? So I need to find, let me label it with X and Y. I need to find BC, which I'm going to call X. And I need to find AB, which I'm going to call Y. All right, to find BC, I'm going to match it up with this corresponding side. This corresponding side is that FG. So I'm going to make the statement BC over FG. Well, BC, I have X standing for it. FG, I have 9 standing for it. X over 9 has to match my scale factor of 1 over 3. That's why I say top and bottom. I knew to put this X on top because of this. I knew to put the 9 on the bottom because I wrote bottom there. And that's going to equal 1 over 3. Well, now it's just cross multiplications. So that's going to give me 3x equals 9, or x equals 3. So I have x equals 3. Well, I wrote that a little big. I need room to find my y, so we'll just put that here. X equals 3. All right, to get my y, our y is side AB. So we're going to do AB corresponds to EF. AB, I stood for y. EF is 21. That has to equal my 1 over 3 once again. Cross multiplication. I've been running kind of big, so I'm going to run a little bit out of room. We are going to have 3y equals 21, which is just going to be y equals 7. So y equals 7. So we have 7 plus 3 is 10, 16, 21. Our perimeter is, let's actually put this down, 5 plus 7 plus 3 plus 6 equals 21 units, whatever we're talking about, feet, meters. But you need to figure out your scale factor. And once again, when I ask for a scale factor, you better put it in the correct order. All right, our next one. Our next one is proving that two things are similar. Proving that two things are similar. This is the step-by-step guide to prove that the things are similar. So the first thing we need to do is prove all the angles are congruent. Do we really want to spend the time and write? It's already on there, right? Do we all agree that all the angles are congruent? Mm-hmm. We're all okay with that. So I'm just going to say yes. I'm not going to sit there and write all of them down. Okay, determine if all corresponding side lengths are proportional. So once again, we're going to do all of the sides that are supposed to be proportional to each other. So FJ should match up with ZW. So in other words, that will be 16. Actually, scratch that. I'm going to change that up. Notice how it says ZYXW to FGHJ. Let's just stick with ZYXW being the top. So anything from here we'll put as the top value. And anything here we'll put as the bottom value. Then we'll have our answer right off the bat. We won't have to do any more work. So that's going to be 20 and 16. We're hoping that's equal to all of the ones. So now we're looking at this 15 and this 12. So we're hoping that equals 15 over 12. We're hoping that equals this 30 over 24. We're hoping that equals that 25 over 20. Well, 20 over 16, 4 goes into 25 times. 4 goes into 60, 16, 4 times, so that's 5 over 4. 3 goes into 15. Hold on. Okay, we're good. No, my thing was just jumping for some reason. So 3 goes into 15 5 times. 3 goes into 12 4 times. And quick spoiler alert, they're all going to work out. They're all going to work out as 5 over 4, so they're all proportional, so it works out. These two shapes are similar. So our similar statement is going to be, doesn't matter how you pick it, I'm just going to say Z, Y, X, W is similar to F, G, H, J, and the scale factor is going to be 5 over 4, and this matches the Z, Y, X, W being on top. That's why I picked it for here, so our scale factor will automatically be set up for us. Questions on that? All right, next one is a little graphing. It gives us a whole bunch of points, and it tells us plot the given points to draw a quadrilateral A, B, C, D. So let's do that first. Let's plot A, B, C, D. So A is at 0. 0, 0. B is at 4, 0. 1, 2, 3, 4, 0. C is at 2, 4. 1, 2, 1, 2, 3, 4. And finally, D is at 0, 2. And it says draw the quadrilateral. That is getting way bad. Still bad. Let me cheat. I'm just kidding. I'm not cheating. This is all free-handed. It's evident in my first couple attempts of the curved. That is my quadrilateral A, B, C, D. Then it says plot A prime, B prime, and draw the line between those. So A prime is negative 10, 0, which is here. B prime is negative 2. I'm sorry. That is negative 10. It should be negative 10, negative 2. It should be. Our B is negative 2, negative 2, which is here. And it tells me to draw the line. Now it says find C and D prime so that A prime, B prime, C prime, D prime is similar to A, B, C, D. So the big thing about being similar is our lines have to be proportional to each other. So I'm going to look at the lines that match up. A to B is 4 units across. A prime to B prime is 8 units apart. That means to go from here to here, I have to multiply the side length by 2. Let's apply that to this D and A. The distance between D and A is going to be 2 units. What is the distance between D prime and A prime going to be? Lydia?
4.
It's going to be 4 units. Because our big thing is here, to get to that 8, we just did 2 times the 4. So this is going to be 4 units high, 1, 2, 3, 4. And this is going to be my D prime. Now it'd be awesome. We can get these measurements. We can do all this stuff. But a slightly easier way is just to look at that height, this height right here. Well, if you look at that height, it intersects the base at its midpoint. So I'm going to locate the midpoint on the A prime to B prime, and that would be 4 units away from either 1, 1. Right here, there's my midpoint here. Then the height between line A, B, and C is 4 units. So that means our new height on our new one is going to be 8 units. 1, 2, 3, 4, 7, 8, 1, 2, 3.
Maybe just do like the rise over run,
Sure, if you want to.
and then just multiply by 2. Or, yeah. Don't multiply the rise by 2 and run by 2.
I would not do that. That would not work.
I just did it.
It kind of worked.
It worked. I didn't mean kind. It worked.
Oh, I see. You multiplied.
So I went from D.
Yes. That's another way. So you were saying it's 2 over 2 units?
Yeah.
And so this is going to be 4 over 4. That absolutely works as well. That's another way to do it. Either way is comparable to each other. So one more time. What Evan did is he said, well, this is 2 and 2. So this must be 4 and 4. Absolutely, that works 100%. Those are 2 perfectly valid ways. All right. Any questions on that? All right, try the next one. Did you have a question on that?
Oh, may I just use the restroom?
Hurry up, because this is your time to show me you know this stuff. I'm only going to give you a few minutes to do it so I can have time to answer questions from homeworks. Yes.
Ratio for which one?
Both. Find the ratio
Both?
of the perimeters.
Oh, the rate. Sorry,
Yep.
I'm thinking. Thank you.
Yep.
Oh, and also my homework. I forgot it in English room.
Okay.
Yeah, I can get it after.
I'm not 1,000% sure I'm going to get to that.
Oh, okay.
I might have to just have a whole bunch of checking on Monday. Because that will be 3 assignments I got to check. Just for the sake of time, we're going to have to do this together because I know there's going to be questions on the homework. Did anyone find the scale factor of F, G, H, J, K to A, B, C, D, E? Hannah?
3 over 2.
You got 3 over 2. Let me just double check. So you probably used this 15 and this 10. And you're probably thinking, well, it said F, G, H on, so that should be my top. This should be my bottom. So you'd have 15 over that 10. Did you say 3 over 2?
Yeah.
Oh, then I agree. Nice job. All right, it says find AE. So I'm going to locate AE. I'm going to locate AE. AE is on the bottom triangle. So it's going to be top over bottom. So we should have did FK. I should have did FK over AE. FK is actually 18 units. AE is X. Well, that has to equal my proportion of 3 over 2. That's going to give me 3X equals 36. Or X equals 12. Do we agree with that? Is AE 12? Did I mess anything up? All right, perimeter. Perimeter. I'm just going to give you the answer, what I got for perimeter. Actually, I think I made a mistake when I calculated my perimeter. So it'll be 20, 30.
46.
Yeah, I got 46.
Yeah, 46. Yep, 46. Sorry, I just realized when I was doing this before that I made a mistake somewhere. So you should get out 46. If you can't, ask questions on that. But I do want to give you guys, because that will give me 10 minutes. Who's got questions from the homework? Yes.
Number 37.
Number 37. Ooh, this is sequences. Number 37. So number 37, I'll start it and then I'll kind of give you the answer. So 37 was, correct me if I'm wrong, but this should be that x times x plus 5 equals 4x plus 4 equals a 9 over 5. On my answer key, I didn't do this, but more than likely, I would distribute that x first. So I would distribute this x before I did anything else. I would distribute this x and rewrite everything as x squared plus 5x over 4x plus 4 equals 9 over 5. Then I would go ahead and do my cross multiplication. So I would do my cross multiplication. And that should result in 5x squared plus 25x equals 36x plus 36. I assume we got there. All right. And then I would subtract 36x from both sides. We have 5x squared minus 11x minus 36 equals 0. All right, as soon as I get there, I realize that I have to factor something. So when I need to factor something, I'm going to create my air conditioning and Beyonce column, where I multiply my A times C, so that's 5 times negative 36. And my Beyonce column is going to be negative 11. So let me kind of print what I have, and then we'll just kind of walk through it. So from there, I did this. Let's see if I'm in the right place. Okay, good enough. All right, so you can see my air conditioning column comes out to negative 180. My Beyonce column came out to negative 11. I'm looking for two numbers that multiply together to give me negative 180, which I boiled down to 9 and negative 20, because 9 plus negative 20 equals negative 11. From there, you split up that middle term into a positive 9x minus 20x. So that's what I did. Positive 9x minus 20x. And now I have 5x squared plus 9x minus 20x minus 36. I break it apart into two binomials. I put a box around the first binomial and a box around the second binomial. I'm going to factor out the biggest thing I can out of each of those. So the biggest thing I can factor out of 5x squared plus 9x is only an x. There's nothing I can pull out of 5 and 9, which will turn into x times 5. That should say 5x, not just 5, plus 9. And then I pull the negative 4 out of that 20 and negative 36. So I have negative 4 times 5x plus 9 equals 0. I know I did everything right because these two sections are the same. That 5x plus 9 is the same as that 5x plus 9. So I can smoosh together my x minus 4, and I have x minus 4 times 5x plus 9 equals 0. X equals 4. X equals 9 over 5. Make sure if you weren't sure how to do that, I guarantee there's going to be one of these like this on the test that you're going to have to factor. So you have to know how to factor. Whether you use my method or a different method, I'm always checking for my method because I think it's the best method because it's my method. But if you have a different method, go ahead and use it. Just make sure you know how.
Okay.
Do all those steps make sense, though?
Yeah, I just got confused with the 5 times the negative 36.
Oh, okay. Yep. You keep going even though it's a big number.
Okay.
Yep. Other questions? Lydia. Number 39. All right, number 39 is just basically giving you two equations. That's how 39 and 40 are.
Like, because if you go from 5 to 5K, you know, the proportion is like
All right. So it just gives us two equations. I cross multiply the top one, which gave me 7y equals 4x minus 36. And then I cross multiply the bottom one, which gave me 3x plus 3y equals 5x minus 5y. Then I convert them to their two equations with the x's and y's lined up. So I would have negative 4x plus 7y equals negative 36 on top. And on the bottom I got negative 2x plus 8y equals 0. Then I went ahead and used elimination. I said, well, if I multiply the bottom by negative 2, I will get a positive 4x down here. So I multiplied the whole bottom by negative 2. Used my elimination property to come up with negative 9y equals negative 36. Y equals 4. You plug that into either one of the equations, and you come up with x equals 16. All right, so it was just setting up two equations. And it's the same thing for 40. If you look, I did the exact same thing. I just set up my two equations. In fact, I did almost exactly the same thing. Then I used elimination to solve those out. So it just gave you two equations you needed to solve for those two variables. Other questions? Yeah.
Number 11.
Okay. Number 11, just the 2 over 5 equals 3x plus 7.
Yeah.
Did I mess it up on here? So we just do the cross multiplication. How'd you do the other ones?
No, I was just confused because I didn't know if like
Oh, okay, just the...
there's the 14 and the 15.
Okay, yeah, the fraction is correct. The fraction is correct. All right, thank you. Other questions? All right, if there's no other questions, go ahead and get started.